Greetings, math fans. All right, so this is day 6, and what I want to do is I want to do a little review here first of some of the things we talked about with the inverse trig functions. Okay, so if I do inverse sine of the sine of 3 pi over 4. Okay, remember 3 pi over 4, you can't just say it's 3 pi over 4. Right? Because this is not in range. That's really, really important. You got to remember. And the range for sine, of course, is between negative pi over 2 and pi over 2. So what you're going to do is you're going to say the sine of 3 pi over 4 is what? Is it positive or negative? And we know we're over here. So the value actually, and all students take calculus, we know it's positive. The reference angle is pi over 4. Okay, that means my answer is in this quadrant right here, and the answer to this problem is equal to pi over 4. All right, let's try another one here. How about inverse cosine of 3 halves? Okay, you guys should realize you can't even do that because, right, isn't this a ratio? And you can't have a ratio of it's x over r, and x is, in this case, x is greater than r, and that's impossible. So this one, this is DNE, does not exist, or as you like to say, do not eat. Okay, and then we have arc secant of negative 2. Okay, and remember you can rewrite that one instead of trying to deal with negative 2. You can say, oh, that's the same thing as arc cosine, because these are ratios of negative 1/2. And the question you're going to ask yourselves is, hey, cosine of what is negative 1/2? Well, ask yourselves first, cosine of what is 1/2? And you guys should remember it's just pi over 3. And then you look at the sign, it's negative. And in cosine, remember, it's between 0 and pi. And so this is negative over here. So it's going to be pi minus pi over 3, which is 2 pi over 3. That's the answer to that problem. Okay, 2 pi over 3. All right, and let's do another one here in the corner here. Inverse tangent of negative root 3. Okay. Kind of the same deal. You're going to say the tangent of what is root 3. Well, remember, it doesn't rule there. Root 3 over 3 is where the 3's rule. So this is going to be 60 degrees, or pi over 3. That's my reference angle. You look at it and it's negative. Tangent is between negative pi over 2 and pi over 2. So, of course, we're down in this quadrant here. So the answer is just negative pi over 3. Okay, just a little quick review, okay, because you guys really, that is like super important stuff. Got to know that. All right, let's talk about solving for inverse trig functions now. And I'm going to ask you guys to solve for x. And you're going to be given y is equal to 1/2 sine of x minus 105. Ooh, that's very scary. And, of course, what we're going to do is we're going to solve for sine of x. So I'm going to add 105 to both sides. I get 1/2 sine of x equals y plus 105. Okay, and then I can multiply everything by 2. So you get sine of x equals 2y plus 210. All right, and then basically what you're doing is you're saying, well, how do I get rid of that sine of x? Well, if you take the inverse sine of both sides, that cancels out the sine of x. Inverse sine cancels out the sine. Of course, it's got to be in range, but we just have x here, so we're good to go. So we just get x equals inverse sine of 2y plus 210. That's it. That's actually pretty easy, right? Obviously, we got an inverse trig function in there, but that's part of the deal. We're solving for x. Okay, that was pretty mellow. Let's try another one here. Now I'm going to actually have an inverse trig function in my example. So 4 inverse sine of y plus 3 pi equals 4 pi. Okay, and I'm solving for inverse sine. So I'm going to subtract 3 pi from both sides. And I get 4 inverse sine of y is equal to pi. Divide by 4. So inverse sine of y equals pi over 4. Well, how do you get rid of the inverse sine? Just like I did before, I took the inverse sine when I had a sine there, but now I'm actually going to take the sine of both sides, because if I take the sine of the inverse sine, I just get y. So you get y equals sine of pi over 4, because I'm taking the sine of both sides. And what is the sine of pi over 4? Y is equal to root 2 over 2. Pretty sweet. Pretty sweet. All right. And then this is our last problem. It's actually a very short lesson. We have 2 inverse secant of x plus 4 pi is equal to 3 pi. Okay, well, let's solve for that inverse secant. So we're going to subtract 4 pi from both sides. So we get 2 inverse secant of x is equal to negative pi divided by 2. So we get inverse secant of x equals negative pi over 2. Okay, and then we should take the secant of both sides. So we'll get x is equal to the secant of negative pi over 2. All right, and then you're like, oh, wait a second. Wait a second. Let's go back. I know you're all excited about just finishing this problem, but I want to go back to this problem. We're so excited about taking the inverse or the secant of negative pi over 2, which you can do, right? Technically you can do, but I want you to understand secant goes with cosine. Don't you guys agree we're between 0 and pi? This is actually impossible. You can't have the inverse secant equal that. It's just like back in the day, just a couple days ago, if I would say, hey, what is the inverse secant of this value? You told me negative pi over 2. I would say it's wrong because you're saying you're in this quadrant. So that's actually out of range. So you can't do that, and your answer is no solution. Okay, because it's out of range. Okay, so you got to realize that. So even if, like, for example, if you came up with, after you did all your work, sine of, or inverse sine of x is equal to pi. Okay, I know it's really tempting to say, oh, I'll take the sine of both sides, and I get x equals sine of pi, and the sine of pi is going to be 0. Okay, then you think that x would equal 0, but it's not the case. Because you got to look at this and say, oh, geez, you can't have the inverse sine be something out of range, so you have no solution. All right, so that's really important to understand that and not just automatically jump to the conclusion. You got to see, hey, what is that inverse sine equal to? Is it equal to a value that's in range? Okay, great. If it is, you got an answer. If it's out of range, you're done with the problem. It's no solution. All right. Anyway, that was a quick lesson, and hopefully this is the end of the chapter, and you got a lot going on here, so study hard. Adios, math fans. Goodbye.